Okay, so we've talked about loops already, and now we want to extend that idea and talk about
Loops of loops.
so where can we see this problem arise? Where can we use this concept? Let's look at an example. So suppose we have a bunch of students, so we have student 1, student 2, up to student 10, and they take tests throughout the semester, so there's test 1, test 2, test 3, and so on. And suppose we want to calculate the average for student 1, what's the average score, what's the average score for student 2, and so on. So if this was a spreadsheet, probably most of you would know how to do it in a spreadsheet, for example in Excel. If you know about Excel, you would probably, over here in this cell, you would use the average function to calculate the average of this list. And then you would just drag that down and you would get the average for each student. So that doesn't seem to have anything to do with loops of loops, but in a sense it does, because we're looping through these values when we calculate the average. And then we're sort of repeating that process repeatedly as we drag down. So there's sort of two loops happening. Maybe we don't think of them as loops, but maybe it could be thought of as a loop of loops. Anyway, that's what we want to investigate now. So we could say, well, how are we going to enter the data into our program? And we might say that we're going to create a variable for the first student. Maybe the first student's name is Jerome. And we'll do this, set Jerome, and set these scores for Jerome. And then we could also do that with the next student. We could set Jenny and her grades. And then we could do that with some of the other students as well. But if we had a lot of students, this would be kind of cumbersome, and we wouldn't really want to approach the problem like this. We wouldn't want to define variables like Jenny, Chris, Andrea, and so on. So we want to look for some other approach to doing this. So let's just take that same data, or these same variables, and write them in a slightly different format, just putting some spaces in here. And when we write it this way, this suggests that maybe we could approach this as like a spreadsheet, or as a matrix, or maybe just as a table. So that's actually going to be what we're going to do. Now just one last thing here. Notice at the top we have the test, but we've labeled this as test 0, and that's because in most programming languages, not all but most, we start counting with 0 and then 1 and so on. So we've done that here as well. Okay, so here is the data, and we've put it into we're taking this data and we're putting it into a table. And here we're assuming that we have 10 students and 5 tests. So we're going to have 10 rows here and 5 columns. And notice here that we don't have the student names and we don't have the test names. So that's because of the kind of data structure that we're going to store this in won't allow us to do that. If we want to, we could use a different kind of structure, but right now we're just going to use this kind of structure that doesn't allow us to store the kind of metadata. Okay, so this is called a two-dimensional array. There's rows and columns, that's called two-dimensional. We might say this is the width and the length, that's also called two-dimensional. Anyway, this is called a two-dimensional array. And we can also think of it as a matrix or just a table. Now, if we wanted to store the names of the students, we might use a different data structure. We might use, in Python, a dictionary, or maybe a three-dimensional array, but we're just going to stick with this 2D array. Okay, now Python by itself doesn't have arrays. There are modules that we can use that allow us to create arrays or use arrays, but we can still construct what we need and basically store this as a kind of a table. Well, let's see how we do that. So here's the way we're going to do it. So we're going to call the whole thing grades, and it has the same numbers that were in that blue table, but let's look at how we define this thing. What is it? Well, you can see that there's a square bracket here, and you can see that there's a square bracket here. So what does that mean it is? It means it's a list, but it doesn't exactly look like a list, because usually we think of lists like, for example, here's a list, and it has 3 elements in it, and the first element is apple, then banana, and then grapes. And so each of the elements in the list is separated by a comma, and then there's two commas, so there's three elements in this list. So but this is also a list because it does start and end with square brackets, but where are the elements, or what delineates the elements? Well, the same thing, commas delineate it, but actually there's kind of a lot of commas here, and it's not all of the commas. It's this comma and this comma and this comma and this comma and so on that delineate the elements of this list. So what does that mean? Well, here we had a comma, so we have an element on either side. So here we have a comma. So the elements, this is an element. This whole thing is one element in this list. And then the comma, look on the other side, there's another sort of similar thing on the other side of the comma. So what are these things? They're not strings, like these are strings. They are what? They are lists. So we have a list, but the elements themselves are lists. And that's the kind of data structure that we're going to store this data in. So what is it? It's a list of lists. So the first element of this grades list is this entire list. The second element of this grades list is this entire list, and so on. Okay, so it's a list of lists, and that sounds kind of awkward and not really what we were after, but it does look like a matrix or a table or a two-dimensional array, and we can treat it that way. Okay, now we might ask, how can we access the values inside this grades array? So we know how to access elements in this list here. We'd say, if this list is called my list, we'd say my list 1, that refers to banana. And so we can access elements in my list using an index. But what about here in grades? Well, here, the way we can access it is we can do something like this. Grades 0, 1. So what is that going to mean? What element is that going to access? Well, we can see the answer here. It's 92. But why is it 92? 0, 1. When we write this 0, 1, this tells us the row, and this tells us the column. So what is the row is the 0th row, which is this one. And the column was 1, which is the second row, which is this one. So we're talking about the element 92. So that's one way to think about how we access elements in the grades, we'll call it array. So we can do this, 0, 1, if we want a different element, we can find the address of that other one. For example, we could say, well, what's the address of this one? So this is in row 3, but we call it row 2 because of indexing. So this is 2, 0. So 2, 0 would be 98 if we wanted to do that. Okay, now there's another way to think about what we wrote here, grades 0, 1, because what happens if I print grades 0? That means we want the 0th element of the grades list. But we said the elements of grades are lists themselves. So the 0th element will be a list, and it's this list. And if we want the first element, it's also going to be a list. It's going to be this list. And if we want, and so on. Now, if this is a list, for example, this one, then we know that we can access elements of a list using indexing. So what would that mean? We could take grades 1, that's this list, and then put another set of square brackets here to access one of the elements. For example, this would be with a 2, right? This is the third element, so it would be index 2. So we could write 1 and then another set of square brackets 2, and that would print out 70. So we can access the elements that way, but that's exactly basically what we just said before. We give the row number and the column number. So it's really the same thing, but it's two different ways to look at it. Now we can also print out all of the elements of grades, just the way we would print out all the elements of any list. Grades is a list. And so we would put it in a for loop, and we would print out grades 0, grades 1, grades 2, and so on, and that's here. Okay, with that introduction to the data structure, so grades is a list of lists, but we're going to treat it as an array. So we're going to say our data structure is an array. We're not going to forget that it's a list of lists, but we're going to think of it as an array. Now we want to do the first task, which is to calculate the average for each student. So typically in a programming problem, when you have a sort of complicated task, you try and simplify the problem. So how can we simplify this problem? So we're going to do sort of a double simplification. So first of all, we're going to simplify by only working with Jerome's tests. We're only going to work with the first row, so that certainly makes it simpler. And then we're going to simplify, at least at first, by only calculating Jerome's sum, not his average. So let's just do those two things first. So we want to calculate the average of the elements in the pink oval. Okay, let me mention one more thing. When we talk about grades ij like this, I'm going to refer to I as the first element and j as the second element. So what do we know about Jerome? We know that Jerome is the first row, or Jerome's scores are the first row in our two-dimensional array. So that is, we want grades 0, because 0 means the first row. But we want all of these, so for example, we want grades 0, 0, we want grades 0, 1, we want grades 0, 2, grades 0, 3, grades 0, 4. So generally speaking, we want grades 0, and then this can change. It can be 0, it can be 1, it can be 2, it can be 3, it can be 4. So we denote it with some variable, in this case j. And what do we want to do with these elements in the pink oval? We want to add them up and then divide by 5 in this case, or divide by m generally. And so when we want to add things up, typically the way we do that in programming is we start with a variable which is equal to 0, and then we keep adding things to it, and we keep adding all the values to that variable. First we add 74, then we add 92 to that result, then we add 64 to that result. That's generally how we do sum. So that's what we're going to do here. So we're going to call that variable that we're going to start, that's going to start out at 0, we're going to call it Jerome's total, or total Jerome. And then we're going to keep adding what? We're going to be adding the grades to 0. So first we're going to do 0, 0. So that's 0, 0. We're going to add 74. Then we're going to do 0, 1. Then we're going to add this one. Then we're going to do 0, 2. We're going to add this one. So we're going to keep updating the total underscore Jerome, which starts out as 0, but keeps being updated with each of the grades in the first row. And so remember, we generally use j for the columns, so we're going to do that here. So for j in the number of rows, and then we're just going to keep updating total underscore Jerome. And once we've got that sum, then what do we have to do? We have to divide the sum by 5, or m in general. And then we can print out Jerome had, and we call that average Jerome, and then we can print out Jerome had an average score, and then we write average Jerome here, and we can see that the average of the elements in the first row are this number here. Okay, so now we get Jerome's average. Now suppose we want Jenny's average, so we have to do that here. So how are we going to have to change the code? Well, we have to change the name to Jenny, but ignoring that, what do we have to do? We don't want the 0th row anymore because that was Jerome. Jenny is the second row, which means the row with index 1. So we need to put a 1 in here, and we could change this to Jenny, and we would get Jenny's average. And what if we wanted the next person, Chris? What if we want Chris's average? What would we do? So then we would take, instead of 1 here, which was for Jenny, we'd put 2 here, and then we would get the average for that person. And so in this way we could get the average for each student. And if there were only 10 students, we could do it that way. It wouldn't be a big headache. But if there were 500 students or 5,000 students, we definitely would not like to do it that way. Now, it seems like we have been repeating ourselves, right? We did the one thing for Jerome, then we did nearly the same thing for Jenny, and then we did nearly the same thing for Christoph. So what does that suggest? When we're repeating something over and over again, that sounds like a loop. So maybe we need a loop. But actually we already have a loop, so what do we mean we need a loop? Well, maybe we need a second loop. So maybe what we could do is repeat the loop that we have over and over again. And what would that mean? That would mean putting this loop into another loop. And when you do that, that's called nested loops. So what did we have to change when we went from Jerome to Jenny? We had to change the first index, or the first element here, from grades 0 to grades 1, and then we changed it from grades 1 to grades 2. So this suggests that what we want to do is take our loop and put it in another loop where these things will change from 0 to 1 to 2 to 3 and so on. So let's see what that looks like. So here, this is the original loop we had for j in range m, and this still has Jerome. But now, instead of 0 here, we're going to have to change this. We're not going to leave it as Jerome, but for now we're just going to copy and paste exactly the code that we've written already. We have it here. But now, except for it's not quite exactly the same, because here, whereas for Jerome we had 0, now we want this to change from 0 to 1 and so on. So we're going to call it I, and we're going to take this whole loop and put it in here. In other words, in another loop. And that loop, the index is going to be I, and I is going to go from 1 to 10, or 1 to n. And let's try running this now. Of course, we didn't change Jerome, so it's going to be Jerome the whole time, but hopefully the grades that are calculated will be different for each row. So we'll get like this. Jerome had an average score of this, and then this person had the next, this is the next person's, and the next person, and we have all 10. Okay, now to fix the name problem, because we had Jerome, 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 we can just make a few adjustments. So instead of saying total of Jerome, we can say total of student I and set that equal to 0. And then we want to keep updating that like this. And here we have I and j. And then we can just change from average of Jerome to average of student I, and so on, and just change these. And finally we get the printout that we were looking for. Okay, so we were able to calculate the average for each student. And now we just want to finish up by also calculating the average for each test. In other words, the average for each column. So when we calculated the average for each student, we were calculating the average for each row. And now we want to calculate the average for each column. So again, let's start out by simplifying the task. And so we will focus just on column 1, or just test 0. So if we only want test 0, we can do something very similar to what we did before, except we're going to refer to, of course, the grades array, but we're only going to do the first column, and so we will set grades I0. So this is the 0th column, or just the first column. And again, we want to set the variable equal to 0. We'll call it the total test for column 0, or test 0. And then we want to iterate through the rows, through the n rows, through the 10 rows. And we're going to update total test 0 each time as we sum up all the elements in the first column. And again, we are keeping this fixed at 0 for now, because we're just working with the 0th column. And we're letting this change. This is the row, so we're sweeping through the rows. And so when we do this for the 0th column, we get an answer. Okay, now, whereas before we had to add in a second loop to iterate through all of the students, we did it for the first student, and then we wanted to iterate through all of the students. Here we've done it for the first column, or the first test, and now we want to iterate through all the tests, so we're going to need to change I0 to IJ. So we're going to have basically another loop again, and this time we're going through the columns. There are m columns, or 5 columns, and the rest of the code is basically the same, except that now we've changed 0 to j, and that's the outer loop variable, or index. And in this case we get the average score for test 0. We also made some naming changes here. Now we get the average score for test 0, the average score for test 1, 2, 3, and 4. So what was our strategy in both of these tasks? It was to write the code for just a single case, and this is generally a good idea. And what do we mean by one case? We mean, as we did twice already, either one row or one column. So for example, we calculated the mean for just one row, i.e. just for one student. We wrote the code for the calculation of the mean for one student. So that is the strategy. Write your code for one row or for one column, and then put that code in another loop that iterates through all the rows or all the columns.